Find the envelope of the family of curves. So you have x minus beta squared plus y minus beta squared equals 1. Alright. Now basically what is going to happen is this. The curves you'll see here are circles. Alright? Let's look at some examples in GeoGebra. I'm going to plot some of these curves. Suppose you have, hold on there, I want to resize this thing. Alright. If you have x squared plus y squared equals 1. You have that curve, right? It is located at the origin and a radius of 1. Just a reminder of some of these things. So the general equation for a circle is x minus, in this case I'm going to use beta, since we have beta already, squared plus y minus beta squared equals r squared. The one that I plotted a while ago, you just said x squared and y squared because it is x minus 0 squared plus y minus 0 squared equal 1 squared, right? Now, let me change it to 2. The radius will be the square root of 2, which is 1.4 something, right? So let's see. Suppose I adjust. By the way, let me make this circle thicker. You can easily see it. So I make a little adjustment here. And instead of 1, I write 2. Now let's zoom in and see where this goes. You see, it's 1, 1.1, 1.1, 1.1, 1.2, 1.4 something, right? If I make it equal to 2 squared, which is 4, it goes to 2, right? And so on. If I make this thing 3 squared, which is 9, goes to 3. It ends up at 3. If I make it 16, which is 4 square, where does it go? Out to 4, right? And so on. You see that? So the thing is, it's equal to r squared, whatever number it is here, it is the radius squared. Now, suppose I make it x minus 1 squared plus y minus 1 squared equals 1. Alright. Before I do it, I can assure you that it's going to move 1 unit to the left and 1 down. So let me make that adjustment. Open bracket, x minus 1 close bracket squared plus open bracket y minus 1 close bracket squared equals 1. Oh, let me see. X minus 1 squared plus, oh, I said a instead of 1. Alright. Oh, minus, yeah. My mistake earlier. It moves to the right and up. Right. When you say x minus 1, it's like you're holding the circle steady and the graph paper shift to the left. Right? Y minus 1, the graph paper moves up. Or down, I mean. So that the circle moves up. Alright? It's not the circle that moves, it's the graph paper move. So you say minus 1. When you say minus, you take things to the left and down. Alright? If the graph paper moves to the left, it would be like the circle moves to the right. So the center of the circle is above 1 and beside 1. If I make this minus 2, the center will be beside 2 and above 2. Right? So if I adjust this, change this 1 to 2 and this 1 to 2, the x coordinate, the center is above x equal 2 and beside y equal 2. And if I say x minus 1 now and y minus 2, the center will be above x equal 1 and beside y equal 2. Right. And if you say plus now, x plus, oh no, a mistake, accidentally touched the wrong thing. Open bracket x plus 1, close bracket. Alright, so the center will be above negative 1 and beside 2, so I expect it to move out here, the center. Okay, and you see it. Alright? Now the thing is, with this, b is a parameter. The radius is fixed. B is a parameter, or beta I should say. Right? And it's the same values here. So I can plot another circle. Right? Let's plot another circle. Let me just copy this formula. Put it here. And say x plus 2. Oh, let me make some adjustment here. I'm going to make this x plus 1, x, y plus 1, or minus. The equation we given contains minus, so let's not mix it up. X minus 1 squared. You have that. And then make this one x minus 2 squared, y minus 2 squared. And you have it right there, right? Another circle. Right? And you could make a third circle. I copy this and paste it here and make it x minus 3, y minus 3, and you have your third circle right here. Alright? And you could make more circles if you want. Now the envelope will be straight lines that touch the circumference of these circles, right? Now, here, what you're going to do, those were just reminders of the equation of a circle and so on and so forth, right? Now, the thing is, how do we deal with this thing? Now, what you're going to do, right, to find the envelope, you're going to differentiate with respect to the parameter beta, because x and y are seen as the original variables. Then you add beta to it. Beta would be like the 1 and then the 2 that I did earlier in GeoGebra, and then I add a third circle and I call it 3, whatever it might be, right? I could add a fourth circle and use beta 4 or 5 or 6 or any other number I want, right? Now after this, you're going to make beta the subject. You're going to make beta the subject of the equation, right? Now, when you transpose to make beta the subject after doing your differentiation, you substitute beta into the given function, right? Now, after that, you're going to work out, simplify what is in the bracket, right? Then you will get a linear equation. Well, it will be two linear equations, right? Those will be the two lines, right, that cover the curve. So, and you notice they call it envelope because it's like an envelope, you know, like an envelope. You have two straight lines, and it's like if you have them in an envelope and you fold the envelope, right? So they call them the envelopes of, in this case, the one parameter family of curves. Family of curve because they have something in common. In this case, they are circles, right? And in fact, not only that, they have the same radius or the same radii. Now, let's see how you deal with this. Differentiate with respect to beta. So you have x minus beta squared plus y minus beta squared is equal to 1. Now, if you should differentiate this with respect to beta, use the chain rule. You have to remember the chain rule. Suppose you have y equal x minus beta squared, and you say, let u is equal to x minus beta. Then dy by the beta, since you're differentiating with respect to beta, is equal to dy by du times du by the beta. Remember, you should be able to do the chain rule mentally by now, you know, especially for this one. Should be, but just a little reminder. Alright, so since u is x minus beta, then y is equal to u squared, right? So dy by du is going to be 2u times du by d beta. You see that the x will disappear as 0, and then this will be negative 1. So it's negative 2u, which is negative 2 times x minus beta. That's what's going to happen. Alright? So, doing it mentally, you would say you differentiate the outside function, so you have, or the outer function, you have something squared, you have 2 times that thing. If you differentiate it with respect to itself, that's what happens when you say you differentiate the y by the u. Differentiate y with respect to u. Then multiply it by, you differentiate the inner function with respect to beta. You get negative 1. Alright? You see that? And then it will be the same story here. You have 2 y minus beta and negative 1. That's equal to 1. No, 0, 0, because when you differentiate 1, you get 0. Alright? I remember what happened over here was just reminding of the use of a chain rule. Alright, so expanding the bracket, negative 1 by 2 is negative 2 times x. Alright, let's not open the bracket yet. X minus beta, if you want to do too many things at once, you might make a mistake. Alright, this is minus 2 y minus beta equals 0. So this is going to be negative 2x plus 2 beta minus 2y plus 2 beta equal 0. So what's going to happen here now? 2 beta plus 2 beta is 4 beta minus 2x minus 2y equals 0. Right? And then you make beta the subject. You say 4 beta equals 2x plus 2y. And then you divide by 4. So beta is equal to, you could factorize this and get x plus y in the bracket over 4. And you cancel down. So you say beta is equal to 2 into 2, 1 to the 4, 2. X plus y over 2 is what you get here. Nice. So that is your beta. The next thing to do is substitute beta into the given function, that's the function of the curve. So it was x minus beta square plus y minus beta square equal to 1. There is x minus beta square plus y minus beta square equals 1. But beta is x plus y over 2. So it's going to be x plus y over 2 squared plus y minus x plus y over 2 squared is equal to 1. Alright, we want to simplify now, you know. But it would be dangerous to try and expand the bracket so quickly to say x minus x plus y over 2 times x minus x plus y over 2 to try to get x squared plus this and that and the other. That's a whole lot of mix up. So what you do? Simplify what is inside the bracket before you do any squaring. Alright, so remember with this now, I could put this in a little bracket and put this over 1. If you use common denominators too, if you multiply both top and bottom by 2, you get 2x over 2 minus x plus y over 2 squared. Plus, and do the same thing with this. This is y over 1. If you multiply the top and bottom by 2, you would get 2y over 2 minus x plus y over 2 squared equals 1. You have to remember your fractions, you know, right? To keep up with your fractions, remember how you deal with the fractions, right? All right. So, what happened here now? This, you can write it as 2x minus or something all over 2. Put bracket, you have to put the bracket here now. X plus y squared plus, same thing here, 2y minus, in bracket, x plus y all over 2 squared equals 1. If you remove the brackets inside now, you have 2x minus x minus y over 2. If you didn't put these brackets here, you might forget that you should negative the y. And you only write 2x minus x plus y and get yourself mixed up, right? All of this is squared plus, what happened here now? 2y minus x minus y over 2, all of this is squared equals 1. Now 2x minus x is 1x. So it's x minus y over 2 squared plus 2y minus y gives you 1y. So it's 1y minus x over 2, all squared equal 1. See that? Now, you already see how long and complicated this this particular problem is. So you have to practice it regularly and catch it. Alright, so what will happen here now? You have all of this x minus y thing squared, right, over 2. This will amount to x minus y squared over 2 squared plus y minus x squared over 2 squared equals 1. So you see what's going on there? So now it's going to be x minus y times x minus y over 4 plus y minus x times y minus x over 4 equals 1. Let's multiply both sides by 4. We have x minus y by x minus y plus y minus x by y minus x equals 4. Because when you multiply by 4, this is what happens. These 4's cancel the 4 that you multiply by, right? All of those would cancel, and then you multiply the 1 by 4 to get 4. Alright, what's going to happen here now? X times x is x squared. X times negative y is minus xy. Y minus negative y by x is minus xy. Negative y by negative y is positive y squared. Plus, and then you see what happens here now. Y times y is y squared. Y times negative x is negative xy. Negative x times y is negative xy. Negative x by negative x is positive x squared equals 4. So you put like terms together. You have x squared And you have another x squared, alright? And you have plus y squared, and you have minus xy, or you have two more, minus xy equals 4. Everything accounted for? Let's see. How many are? 1, 2, 3, 4, 5, 6, 7, 8 things separated by plus or minus. 1, 2, 3, 4, 5, 6, 7, 8 things separated by plus or minus. We didn't miss out anything. Alright. Oh, this is a square. Yeah. So this is 2x squared plus 2y squared plus, well, it's minus 4xy equals 4. Alright? So you see what's going on there? Now, suppose you divide both sides by 2. You get 1x squared plus 1y squared minus 2xy equals 2. So, you get that. Now, let's rewrite this thing. Because we run out of scrolling space, we can't scroll down anymore. Alright. This kind of question causes a lot of stress on the brain, you know. You have to make sure you practice it. X squared plus y squared minus 2x. So you have x squared plus y squared minus 2x. X squared plus y squared minus 2xy, equal 2. Minus 2xy equals 2. Alright. Consider this to be a quadratic equation in consider the left hand side to be a quadratic expression in x. So you have x squared minus, right, it has 2y x plus y squared equals 2. We're going to factorize the left hand side using the AC method. Now, you have to remember the AC method. It says if you have ax squared plus bx plus c, the quadratic function, a times c will give you AC. You find two numbers that multiply to give AC and they add to give B. And those two numbers you use in factorizing this thing. You're going to divide the middle part into those two numbers. Now the middle part here. You can write this as plus negative 2y times x. Now, what's going to happen here? In this case, a would be 1. B would be negative 2y. And c is y squared. Alright? Once you remember your AC method. Now the thing is, a times c is y squared. Now, which two numbers multiply to give y squared and add to give negative 2y? Well, if you think about it, you will see that there are negative y and negative y. Because negative y times negative y gives you a positive y squared. Negative y plus negative y gives you negative 2y. Alright? So what happened here is you have x squared in the middle. You have negative yx and negative yx minus yx minus yx. That will give you the negative 2yx, right? Plus y squared equals 2. Remember, you're working on factorizing the left-hand side alone. My gosh, why the right 0 there? You're not going to trouble the 2 out here yet. Just concentrate on this part for now. Factorizing pairs. You have x outside the bracket here, x minus y. Then what happens here now? If you put negative y outside the bracket, negative y into negative y, x goes positive x. Negative y into positive y squared goes negative y equals 2, right? If you multiply them out back, you see negative y by x gives you negative yx, negative y by negative y gives you positive y squared, right? Now, x minus y times, when you would take this out as a common factor, x minus y, and then you have the x here minus the y here equals 2. Alright? You see that? Now, this means x minus y, oh boy, x minus y squared equals 2. Alright? So, x minus y, if you square root both sides, you square root of x minus y squared is going to be the square root of 2, but it's positive and negative square root of 2. So you have x minus y equal positive and negative square root of 2. Right? Now, negative y is equal to positive and negative square root of 2 minus x. Or I could put the minus x first to make it look more like y equal mx plus c. So minus x plus or minus square root of 2. If I multiply both sides by negative 1, I have positive y equals positive x minus and plus. Right? Even though it's the same thing as plus and minus. Alright. Write it this way, because when you multiply negative 1, the plus at the top become negative and the minus at the bottom become positive. Square root of 2. So that is the envelope. Now let us see how this works. Now, we see here in GeoGebra, we have 3 of the circles already. These are x minus 1 squared plus y minus 1 squared equals 1. It's just that I want the parameter beta to be 1. Could be 2 or 3 or whatever it is. Now, oh, I didn't put the square root part here. I just realized square root of 2, right? Now, let's plot the graph for y equals x plus square root of 2. By the way, what square root of 2 again is 1.414. Let me see on my calculator. 2 square root here, 1.414. Y equals x plus 1.414, and then y equals x minus 1.414. And see what they look like. So it's y equals x plus 1.414. Alright, so that's the line. Let me make the line thicker. And y equals x minus 1.414. That is the other line there. Let me make the line thicker. Alright, so you see what's going on here. Oh no, I accidentally shifted. Let me undo. Right. So you see what's going on there. Alright. Oh no. I jumped back out. So in this case, you have the envelope. Take envelope means to enclose. It encloses the circles or the curves. Alright, so that is that. We have our envelope of this one parameter family of curves. Don't forget to practice this question until you can do it on your own, right? You have to practice this question over and over again and make sure you can do it without looking back at the solutions. Alright, so I'll see you in the next video.